Welcome to Landscape Irrigation Week 4. This week we're going to be talking about Chapter 5 out of the Rainbird Landscape Design Manual on selecting sprinklers and spacing ranges. This is a long chapter, so I'll be breaking it into two, and the second half will be next week. Factors to consider when choosing the right type of sprinklers. The type of sprinklers requested by the owner, the size and shape of the area to be watered, types of plant material to be irrigated, water pressure and flow available, local environmental conditions such as wind, temperature, and precipitation, soil type and the rate at which it can accept water, compatibility of sprinklers, which can be grouped together for matched precipitation, and then are sprinklers the most efficient method, or would drip irrigation be a better choice? We're going to be breaking these down one by one. Give customers the type of sprinklers they request. Well, for the most part, this can be done. So sometimes customers might have a particular sprinkler that they've used before and liked. They may have a type of sprinkler that they used before and didn't like. They might like the way that something looks, sounds, or performs. What you want to make sure is if the sprinkler they're requesting will work for this particular site. So here's some things to keep in mind. First, you want to make sure that the soil infiltration rate can handle the application rate that their desired sprinkler wants to put down. Then, is there a slope to contend with? If there is a slope to contend with and the sprinkler head that they choose has a higher precipitation rate, then that might not be the best choice. If you decide to use that type of sprinkler head, then it'll take management in order to make sure that that doesn't create runoff. And sometimes even a minute is too long. So keep that in mind, that if you use a sprinkler head that's too high of an application rate, you may have to have numerous start times during the day to accomplish what you need to accomplish. And then also, is this the most efficient option? Is there an alternative sprinkler that may work just as well that has a higher efficiency rating? If so, you may want to hear them out, hear what they have to say about the sprinklers that they want, and then also offer them some alternative options and explain the efficiency of the suggested sprinkler versus the sprinkler that they would like. Another issue could be wind. If this is in a windy area that's different than what they used to have, that might be a consideration for them to think about. We're going to talk a little bit more about wind issues coming right up. What is the size and shape of the area, and what types of plant material are you working with here? So this example design is the one that's throughout the Rainbird textbook all the way through. And you can see in this particular planting area, we have these meandering strip planter beds that look like they would be best to use drip irrigation rather than sprinklers, because they look narrow and they're also really curvy. So the curvier something is, the more likely you're going to have overspray. So if you're able to use drip on those areas, that might be a better choice. Then also we have these narrow or small turf areas that are going to require shorter radius sprinkler heads. You won't be able to use a large radius sprinkler head in that area, or you'll have excessive overspray. Then sometimes you have just a really weird, funky shape that you might consider using subsurface strip for that to avoid any overspray there. And then if you have areas with straight edges, like you have on this edge of this lawn, that's a spot where you'll have less overspray because it isn't curvy, and they'll have fewer opportunities for that to spray over. You'll want to make sure that you have adequate water pressure and flow available to use the type of sprinkler heads that you have in mind. So manufacturers have specific required pressure and flow ranges for their products. So you'll want to take a look at the manufacturer's specification sheets and make sure the pressure that you have to work with and the flow that you have to work with is practical for what you're looking for. You'll need to make sure that you've verified the available operating pressure and will be able to accommodate the type of sprinkler that you'd like to use. Spray sprinklers are typically used for smaller areas that have shorter radius than larger areas. So a spray type of sprinkler isn't something that you would see like in a baseball field or a football field because you'd need way too many of them. A typical range in radius would be 4 to 17 feet or up to 18 feet. And the typical required flow for nozzles like this ranges from about 0.3 all the way up to 5 gallons per minute. So on this chart here, you'll see that I have circled 30 psi and 15 feet as the radius. So if you have 30 psi, the radius is going to be 15 feet. You'll see for all of these different nozzles here. And these spray heads over here show the typical heights for different spray heads. That's a 4-inch, a 6-inch, and a 12-inch. Rotating or rotor sprinklers are typically used for larger areas that require a longer radius than spray sprinklers are designed for. The pressure at the nozzles for these particular type of sprinklers ranges from about 30 to 100 psi. Typical ranges in radius is anywhere from about 20 feet up to 100-foot radius. The flow range for these is as small as 0.5 and up to about 80 gallons per minute. So there is a large range of different rotors. So you'll want to take a look at the manufacturer's specification charts and find a rotor that will do what you want it to do and doesn't do much more than you want it to do, so you aren't asking a sprinkler to do less than what it is normally designed to do, and try to stay within the range of what you have available. Now, rotary sprinklers are typically used for small to moderate sized areas. Their optimal pressure at the nozzle is 40 psi. The typical range for these are from 8 to 35 feet, and the typical required flow range is from about 0.25 to 4 gallons per minute. So these are rotary nozzles, not rotors. And you'll see in this image here to the right that you can see that this nozzle right here is actually what's rotating, not the actual shaft or just the head of the body moving back and forth. So on-site environmental conditions such as wind, temperature, and precipitation. So in this particular example, I'm going to be talking about wind. So when you have a rotor sprinkler, they typically have a trajectory or an angle of about 25 degrees. So this image on the left on the bottom shows a sprinkler head that is likely about 25 degrees. The problem with that sometimes is if you have wind. So you can imagine if the wind was blowing and you have a trajectory of 25 degrees and you are spraying into the wind, it's not going to be real effective. The other thing that happens is if the wind is blowing in the direction that the sprinkler is going, it could be carrying it off to a place that you don't want the spray to actually land. And then over on the right here, you'll see that the nozzle trajectory for these lower angled nozzles is 13 degrees. And you can see from this image below that the angle is much lower. So that can help you to contend with wind if wind is an issue. But there are some limitations for that. And that is over here on the right-hand side, this is the nozzle assortment for this particular PGP or I-20 sprinkler from Hunter. And the chart on the left is standard 25-degree nozzles. So you see you have fewer choices to work with. The other thing is, in comparison, if you look at this nozzle here, which is 2.5, which is an indication of the approximate flow rate for that nozzle, it has a range of about 35 feet. Now over here on the right, the 2.5 low angle has a flow rate of about 2.5, but has a radius of 33 feet. So you're not going to be able to travel as far, and the flow rate is slightly higher than the traditional 2.5. So you can you're going to add a little bit more flow rate to be able to get as far as you would like to get and still keep it at a low angle. So that is also a limitation. So one thing you might want to find out is it always a windy condition where you want to put these rotors, or is there a certain time of the day when it's windy? You may have to just modify your schedule of when you're actually irrigating, but also staying within the restricted time windows if that applies. Now for smaller radius sprinklers, which would be more typical for a residence or just intricate sort of smaller pieces on commercial properties, would be to use spray heads. So something to keep in mind is the shorter the radius that you have to work with will also be a lower trajectory. So here you have a 5-footer and an 8-footer. The trajectory is 0 degrees for both of those, so it's just completely flat. And then as you start creeping up in radius, so does the trajectory. So for this 10-footer, it's 15 degrees. And then once you get down to 12 foot, 15, and 17 feet, they all have a higher trajectory of 28 degrees. So keep that in mind if you have a windy situation, that the farther you need that nozzle to go, the higher it has to launch to get there, and then wind becomes a problem. So something you might want to consider, instead of using a solid spray pattern that has a smaller droplet size, is choosing a multi-stream, multi-trajectory nozzle that has a larger droplet size. And you'll see over here in this chart, they don't list the trajectory for the MP rotators because it is a multi-trajectory nozzle, which means that the streams are coming out at various different trajectories as they emit from the nozzle. So keep that in mind, that although they are a lower flow, they have these directional streams that have a larger droplet size, so they're less prone to be taken off in the wind. Another on-site environmental condition to consider is temperature. So if you have high heat locations or high heat periods of time, it may require increased frequency to avoid drying out too quickly. And what I mean is, if you have a particular zone on your property that's a little hotter than other zones on the property, you may have to have them on a separate program, which we'll talk about later a little bit more, but you may have to irrigate it more frequently, where you might be able to get away with a couple of times a week for part of the property. You may have to water either every day or every other day, or just more frequently, to make sure that that particular zone doesn't dry out too quickly. So one option that you have is something called cycle and soak, which we'll get into more when we get into controllers. But basically, you take the amount of time in a day that you'd like to irrigate, and you break it up into several pieces. So if your zone requires, let's just say, 12 minutes a day, you could break that up into 3 or 4 or 6 times a day into equal run times, and you could be irrigating for 3, 4, 6 minutes to accomplish that. Another option would be multiple start times, as long as if you had 2 start times, then you would run it for 6 minutes each start time to be able to keep up. What you want to be cautious about is having higher flow rate nozzles, trying to basically just give it more water to make it happy, because you want to make sure that your soil infiltration rates can keep up with the amount of water that you're providing, and you want to avoid runoff. So that's where cycle and soak, multiple start times, and also keeping your precipitation rates a little bit lower can help out with that. Here we're going to talk about precipitation and soil type considerations. This chart here we talked about earlier, and it basically spells out how much water you can apply to different types of soil in an hour and have that soil be able to absorb it. Now, also, that amount of water that it can drink will change over periods of time and how long that you're actually applying it, but this is just a general chart. Down below here, we have charts that show how fast water is being applied in inches per hour and whether that particular sprinkler head is compatible with the type of soil that you have. So here you see this red box that I have put around these different types of soil and pointing at this MP rotator. You'll see that the precipitation rate is about 4/10 of an inch an hour, and up above in this chart, that's compatible with every soil type that's up there other than heavy clay or clay loam. Now, if you take a look at the chart on the right-hand side, you'll see that the precipitation rates are much higher, and this particular nozzle is about 1.78 inches of water in an hour. And then if you compare that with the chart above, where I have put it in a green square right here, that is compatible with only more coarse soils, lightly sandy soils, coarse sandy soils, and anything below that that's a little bit tighter soil means that you're going to hit the runoff point quite a bit faster than you would if you had sandier soil. So what you want to do is try to make sure that you're not applying water faster or much faster than the soil that you have can drink it up. And that's not always possible, or sometimes you've inherited a system. One thing to consider is taking a look at replacing nozzles that are the higher precipitation rate with those that have a lower precipitation rate so that you can better match the infiltration rate. So now we're going to talk about compatibility of the sprinklers and which can be grouped together. So these are the same charts I had on the last slide, but you can see how they look when they're operating. They're obviously different looking. We have a solid pattern on the right and a multi-stream, multi-trajectory nozzle on the left. And the amount of water that they put down is not the same. So if you had these two types of sprinklers on the same zone running at the same time, it's almost like you have a really black cloud spraying water on one side of the zone where you have a light puffy cloud that's irrigating on the other side of the zone. So they're not compatible, and that's greatly going to diminish the efficiency of the system, and most likely is going to cause runoff in some areas in order to try to apply enough water to the lighter zone portion of the zone. So keep that in mind, that you want to stick with normally the same brand and the same series of nozzles together to make sure that you have that match precipitation. And we will talk about that a little bit more in the next session. Okay, and last, you want to ask yourself the question is, are sprinklers the most efficient method, or would drip irrigation be a better choice? Like I pointed out earlier when we were looking at the diagram, sometimes when you have a really odd shaped area, you might want to consider using subsurface if it's a turf or ground cover area. And if it's a landscaped area that is not turf or ground cover, then you might want to ask yourself why you're considering spraying it in the first place. So here on the left-hand side, we have an image of point source irrigation and various different flow rate emitters. And here on the right, we have a system which is a gridded system, which is inline emitter tubing, where it is put in at specific emitter spacings and lateral row spacings according to your soil type. And again, we have this familiar soil texture chart and application rates that are compatible. And below here, we show on this chart various different precipitation rates and the type of soils that they're compatible with. So you see that some of the math has already been done for you, and once you have your soil type figured out, then it's much easier to decide which type of tubing, emitter rate, lateral row spacings, application rates will be a little bit easier to pick out. So next week we're going to be talking about Chapter 5 again, only we're going to be moving on to calculating precipitation rates and determining which is the best type of spacing to use. So next week will be a little bit more math intensive, and so be prepared to pull out your calculator.